Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining content in college mathematics courses, please consider subscribing because you are in the right spot. That said, let's get into the current video. I'm going to discuss how to find the inverse of a function, and this is going to be something that you will be introduced to in your algebra courses, your pre-calculus courses, and then of course you'll need it in calculus and on from there. But let's go ahead and get into the idea. The inverse of a function satisfies the following properties. If I perform the operations consecutively, they cancel. In other words, think about taking whatever number you start with, I add to, and then I immediately subtract to. So I perform those operations consecutively, they're going to cancel. That means that these compositions would both reduce to just x. Simple example to illustrate that idea, let's say I give the function f of x is equal to x plus 2, and the inverse. Well, again, before I write it, even though I've already mentioned it, the idea of an inverse function is that it's going to do the inverse operation to an input as compared to the original function. What this original function does, it takes the input and it adds 2 to it. Therefore, the inverse function would subtract 2 from the input. Now, let's see what happens when we take the composition of those two. F composed with its inverse. Remember, the function on the right is what I'm using for my new input. Therefore, this is f of f inverse. Now, what does the original function do to an input? It takes that expression or that input and it adds 2. That means I'm going to take f inverse of x and I'm going to add 2. Now, let's replace the expression for the inverse with the expression that we stated down here, which is x minus 2, and then we still have the plus 2. Notice that the minus 2 plus 2 cancels, leaving with just x. Again, verifying or illustrating the idea that the consecutive operations are going to cancel. Now, again, down here, I told you what the inverse was, and it's not too difficult to guess in this particular case because this is a pretty simple function. But what happens if we did not know this? Well, let's go through this string of equalities right here. I know that, whether I know the inverse or not, I know that the following is going to happen. When I take the composition of those two functions, I'm going to get x as a result. Now, if I string through this list of equalities, notice going from here to here, I actually plugged in the x minus 2. Well, let's say we didn't know what that was going to be. Well, here's what I know from going from here to here. Let's say f inverse of x plus, well, here, let me write it this way. I know that x is equal to f composed with f inverse of x. And in this particular example, I know that f composed with f inverse of x was also given by this expression right here, which means I have f inverse plus 2. Again, so at this stage of the game, I'm kind of pretending like I don't know what the inverse was. Well, this is an equation, and if I think of this as my unknown, let's go ahead and solve for it. Subtract 2 to the other side, and I do get f inverse of x is equal to x minus 2. Okay. So this example not only kind of illustrates the property right here that the consecutive operations are going to cancel, it also kind of hints at a method for finding the inverse expression if I just don't know what the inverse was. If I start with the function and want to find the inverse, I'm going to start with this equation right here. And from that equation, I'm going to, using the fact that I know what f is, I'll plug the inverse into that for where x goes, right? That's how composition works. I plug it into the input location. And then I will take this expression, set it equal to x, solve it for the inverse. So let me go ahead and do a variety of examples using that. let's say f of x is equal to x to the third minus 7. Find the inverse. Okay, so x cubed minus 7, find the inverse of that. Now notice that this one is slightly more complicated than the original function that I put up there, the x plus 2. The difference being that x plus 2 has one operation where this actually has two operations. What am I doing to the input? I'm taking it to the third power, and then I'm taking 7 units away from it. So I have a little bit more of a complex structure there, right? So let's go ahead and see how this would work. I'm going to start with saying x is equal to f composed with f inverse. Okay. Now when I take the composition of f with f inverse, again this means that I'm using f inverse now as my new input. And where does the input go for the function f? Well, it goes underneath the cube and then before the minus 7. That means I have x is equal to f cubed, or f inverse cubed minus 7. This step right here is analogous to this step over here, where I then use the inverse function, or I thought of the inverse function as my unknown and then solved for it algebraically. That's what I'll do over here. Now if I'm going to solve for this algebraically, the first thing I'll do is I'll add 7 to the other side. I get x plus 7 equals the cube of the inverse. And then to get rid of the cube, of course, I'm going to use the cube root. Notice I'm using the inverse operations all along the way. To get rid of this minus 7, I use a plus 7 on both sides, the inverse operation of this. To get rid of the cube, I'm going to use the cube root, which again is its inverse operation. And that gives me the following. The inverse function is the cube root of x plus 7. Okay. Let's do another example. This time, let's have two different occurrences of x. And usually the example that you first see with multiple x's is some sort of a rational function with a linear on top and a linear on the bottom. In other words, something like this one. 2x plus 3 divided by 5x minus 1. And then once again, of course, find f inverse. Okay, let's go ahead and do that. Setup, of course, is very similar, right? I'm going to start with this exact same first equation. X is equal to the composition of the function with its inverse. And then same second line here, f evaluated at f inverse. And of course, in practice, if you could just start right here, this going from here to here, I mean, it emphasizes the fact that you're using composition, but you know, in practice, go ahead and start with the second step. Okay, so now let's go ahead and plug this in. I get x is equal to, now for this function f, notice that the inputs go after the 2 and after the 5. So I got the input location is in the numerator and in the denominator. That means I have to write the f inverse in both of those spots. So I get 2f inverse plus 3 divided by 5 f inverse minus 1. Now what I have to do, again, is algebraically solve this equation for the inverse function. That will give me an expression for the inverse function. All right. Well, one thing that I'm going to do to start this, notice I've got f inverse appearing in both the numerator and the denominator. I have to group together the inverse terms. In order to group together the inverse terms, I want to get it out of the denominator, so let's go ahead and eliminate the entire denominator. That means I'm going to multiply both sides by the expression 5f inverse minus 1. Okay, so multiply both sides by that expression. And what that would give me is x times 5f inverse minus 1 equals twice f inverse plus 3. And I'm going to go ahead and clean up the other side. So think about what I could do with that for a next step. Okay. I've got an inverse term on both sides, so if I want to solve for it, I need to put them on the same side. In order to put them on the same side, the first thing I'm going to have to do, should be an x there. I'm sure you noticed that. Oh, actually there was, it just looks like I erased it. So I'm going to go ahead and distribute the x through the parentheses. I get 5x times f inverse minus x is equal to twice f inverse and then plus 3. Notice what I can then do is I could subtract this term to the left side and I could add x to the right side. That would give me 5x f inverse minus twice f inverse is equal to x plus 3. Both of these, so here's what I have. Everything that's on the left side has a factor of the inverse. Everything that's on the right-hand side has no f inverse terms, okay? Next thing that I can do is take the inverse, the label for the inverse function, and factor it out. So let's go ahead and do that. I get f inverse multiplied by 5x minus 2 is equal to x plus 3. And then the last step should be clear. I have one occurrence of the inverse of the label for the inverse function, and then it's multiplied by this expression. Therefore, all I have to do is divide both sides by that expression, and I get f inverse is x plus 3 over 5x minus 2. Therefore, this is the inverse function for this one, meaning that if I plug a number in to this function here, and I get whatever I get, I take that number, then plug it into the inverse, it's going to undo all of these operations, giving me back the original value. So you can go ahead and try that. Say plug in 0, and you're going to get 3, and then if I take 3 and plug it into this, well, what are we going to get? On the top, I'm going to get 6. On the bottom, I'm going to get, so 5, 3, 15. So let's see, let's go ahead and do that. Let's write it out. So if I was to take f of 0, notice if I plug 0 in here, I get 0 on the top, 0 on the bottom, so 3 over negative 1, which would be negative 3. And then I take negative 3, plug it into this function. F inverse of negative 3 is going to give me negative 3 plus 3 over 5 times negative 3 minus 2, which is 0. So plugging it back into here got me back to the original value. Again, just as a check that that was the correct inverse function, and to remind you what the inverse does. It just kind of undoes everything that the original function did. That said, thank you for watching, and please consider subscribing.